what the rate of insurance is, and then people can decide if they really want to use that system or if the insurance is too high for them, so they won't use it. That's basically the free market approach. Then we have the nuclear approach, which is the state tells you what you can run and how. The reason for that is because nuclear energy stuff most of the times cannot be fully insured. So if you have a nuclear power station going wrong, it's a little bit difficult. So most insurances terminate at 500 million payout. And if a nuclear power station contaminates a whole country, then it's probably a bit more. So that's why there are certain areas of technology where the state actually mandates in a number of states what can be run. And then we have the German approach, the TÜV. And the TÜV is even more fascinating than most of you think. For those of you who are not from Germany. The TÜV has been founded in the age of steam engines. When the first steam engines were installed, they tend to blow up. Actually, they tend to blow up a lot. And it was rather ugly. And at some point in time, people tended to say, not in my backyard. And so what happened was that the actual engineers running the steam engines and the engineers building the steam engines were getting together over beer in the evening and were discussing what could be done. And what they came up with was the Dampfkesselüberwachungsverein, which is a really cool German word, and it's meaning the Steam Engine Monitoring Association. And what these associations did was they came up with technical standards how they could make steam engines safe. They were saying, okay, if we have a steam engine and it's new and untested, we want to have certain tests run on it, like using it with double the normal pressure and see if it blows up in a safe area, not in the backyard. Or if we have basically a certain type of steam engine that we have seen before, it's okay if we test it with 1.5 normal pressure, because we don't want to blow up too many machines. And we only want to run steam engines at a certain amount of pressure based on construction data and so on. And we need to make sure that the valves are regularly monitored and serviced, and we need to make sure that only certain grades of steel are used for the steam engine boiler. And we want to make sure there's always enough water in there, and so on and so on. So they came up with a set of very basic regulations. And they found out that actually their employees found it interesting, because finally they had a framework, and follow that framework you could install steam engines also in backyards again. So it was very simple. Basically the technicians were coming up with regulations and rules. They were testing them out, they were discussing them with their peers, so making sure it's not totally stupid. And then they convinced everybody else that it's the way to go. And then something really fascinating happened. It was the time when Germany was unified from very many little states that had all their Dampfkesselüberwachungsvereine into a large German Reich. And along came Otto von Bismarck, who basically instituted these Dampfkesselüberwachungsvereine as the way to regulate risky technology. Basically, if it has a TÜV approval, you can run it. If it has a TÜV approval, you can get insurance for it. Of course, the whole system deteriorated and diluted after a while, so today there's not only one TÜV, but there are many entities that you can basically be a registered entity for regulating such technology with a certain level of expertise and a certain number of engineers and so on. But the basic principle is developing the rules from the bottom up and not designing them at the green table. So if you look at what elements for regulation of robotic systems would be good, this is subject of discussion, so it's not something that I tell you that that's how it is, it's just something that we should think about. The first thing is identification. If you have a remote control system or a semi-autonomous system or a fully autonomous system, you really want to know who that thing belongs to. So, of course, if it's a legal entity, it can belong to itself, but still you want to know who it is. So you want to know who's controlling the damn thing and who I need to call when it runs me over. Or, of course, there are easy cases. Like, let's say you are in the Pakistani borderland and something flies above you and fires a Hellfire missile at you. It's probably the CIA owning that thing. So there's not much doubt about that. But there are other cases that are not as easy. So identification is something that is very well ingrained also in cars. For instance, cars have license plates. And these license plates make sure that you can identify this car has done something wrong. It ran me over, or it had an accident, or whatever. And so there is a sense of attribution and a sense of responsibility that can be, of course, it has loopholes and is imperfect and everything, but at least it's a system. The second thing is insurance. Insurance for robots will be the hot topic of the whole thing, because, of course, the first impulse of the industry is saying, yeah, let's insure this shit and then we ship it. So it's not compile, ship it, it's compile, insure, ship it in the future. And so the insurance companies will more or less in the beginning have the power to make or break robotic and automated systems, because if things cannot be insured because they're deemed too risky, then they cannot be shipped. So we have the interesting case at the moment for UAVs, the little drones that the motor drone people are building. If we want to fly such a thing to take pictures in the US, there's only one insurance company at the moment that is insuring that thing. All the others are just sitting there saying, yeah, let's watch how many risks are associated with that, so if that falls into a power line, or if that falls into a car, or if it falls down and kills somebody, or even if they take non-appropriate pictures with that thing, is there an insurance risk? The question is, it can get very complicated. For instance, if you look at Japan, they will have healthcare robots there. We're seeing a few examples later on. So robots that help you in your home, these things are too expensive to buy. So they will be in the region of $100K. So the only thing to get them into the market is rent them out. And say, okay, this is the robot, you pay, I don't know, $150 a month, and you can use that thing. And so who is responsible now for anything that's going wrong with that robot? Is it the person who rents the robot? It's the person who rents out the robot? Is it the manufacturer? Is it the sub-manufacturer of some part? Is it the manufacturer of the software? This whole thing has a higher complexity than a car. At the moment for cars, it's quite simple. So if your car breaks down, you go to the manufacturer, have a warranty. But even there, it's already complex enough. So for instance, Volvo had an incident where the brakes were failing on a certain line of cars, and there were a number of deaths. And it took them, I don't know, I think 11 years until the court procedures were finally done, and it was determined that Volvo was really guilty of the whole thing. And you can imagine how complex that gets with robots once they start interacting with humans. Of course, there's another way to do the insurance thing.
His husband passed away. The insurance company said his policy didn't cover them.
They had no money to pay for the funeral. It's so hard nowadays with all the gangs and rap music.
What about robots?
Oh, they're everywhere.
I don't even know why the scientists make them.
Darren and I have a policy with Old Glory Insurance that covers us in case we're attacked by robots.
An insurance policy with a robot plan?
Mm-hmm.
Well, certainly I'm too old.
Old Glory covers anyone over the age of 50 against robot attack, regardless of current health.
I'm Sam Waterston of the popular TV series Law & Order. As a senior citizen, you're probably aware of the threat robots pose. Robots are everywhere, and they eat old people's medicine for fuel. Well, now there's a company that offers coverage against the unfortunate event of a robot attack. Old Glory Insurance. Old Glory will cover you with no health checkup or age consideration. You need to feel safe. And that's harder and harder to do nowadays because robots may strike at any time. And when they grab you with those metal claws, you can't break free because they're made of metal and robots are strong. Now, for only $4 a month, you can achieve peace of mind in a world full of crime and robots with Old Glory Insurance.
Robots! They're coming! Robots!
Oh, it's a friendly robot. This time.
So don't cower under your Afghan any longer. Make a choice. Old Glory Insurance. For when the metal ones decide to come for you. And they will.
So we see insurance as a fascinating topic. Okay, if we come to responsibility, how do we define if someone or something is responsible for something? There's a huge debate on that in literature, but in general, it implies you can be responsible if you understand what's happening, if you have a system and you can in reasonable terms predict what it will do, like I have this car, I step on the brake, the car stops. I step on the gas, the car drives. I turn the wheel and it goes roughly in the direction I intend. So you're responsible for driving that car. If you don't have that, because the system is not transparent and not deterministic, if it behaves more like, let's say, a pet, a dog, or your little tiger, or whatever, then it's getting harder. So then there's the added element of surprise, you cannot really predict, and robots will be like that. So robotic systems will not be having a will or a soul or something like that, but they will be driven by complex software that is not really predictable. So if you have an Aibo, this little Sony plastic dog, these things could get rather unpredictable. And you can develop software for them that makes them wholly unpredictable. So there have been experiments of motivational learning on them, where the people who developed the software could not really say what these things were interested in. So if you look at the whole domain, we have, with all kinds of technology, we have this interesting gray area. That's that one here. So if we transpose that again to cars or to vehicles, we have the controlled area, which is cars that have above a certain grade of kind of motor, and it can go above a certain speed and have a certain weight. It's relatively simple. It's just a function of power. These are controlled. You can only drive them on roads when they have insurance and all the other things. You have the illegal cars, so stuff that are plain illegal, and then there's the gray area. With robots, it will be the same thing. So when we say responsibility means maybe man in a loop. That's how the military does it at the moment. So they say the final fire command is being given by a human. The robot doesn't fire itself. Then the human is basically a button pusher. So the machine is the button, he presses, it fires. But things evolve. So for instance, in modern military airplanes, you have already automated targeting systems that suggest targets to you. Because the computer is much faster. It has better image recognition capabilities. It can fuse in the radar signals. It can basically do a lot more things than a human can do at one time. And it suggests the most juicy target to you. Of course, it is left to you to press the button. But the target itself, the choosing of the target, is getting more and more automated. And the next step is then, of course, the thing develops into an entity. It becomes an it. It gets names. It has certain characteristics that you implicitly associate with it, and you're becoming a partner to that thing. So not pressing the button anymore, but you're talking with Linda, and Linda is your flight control system. So there has been some work on how that will evolve. So it starts with manual control. It evolves further to action support, meaning the automated system is offering you alternatives. You choose from a given set of paths that you can have. It can go to decision support, meaning that you're not doing the actual action anymore, but you just have these suggestions and say, do this. It goes further to blended decision making, basically what you have today in power control systems. The system actually decides for you, and you just have the right to veto. So if the system does something entirely stupid, you can push the red button. but that's it. Otherwise, it's left to its own devices.